very good morning, my dear students. In this session, we are going to continue the numericals of law of conservation of linear momentum topic, right? So what was our topic here? Law of conservation of linear momentum. In short form, we will be writing it as LCCM, Law of Conservation of Linear Momentum. Okay. This is LM. Clear? Now, so I am not going into the definition of the linear momentum, but what we are doing is, according to the law of conservation of linear momentum, we had already discussed there is a body of mass m1 which is moving with some initial velocity u1 in this direction. There is another body of mass m2 moving with some initial velocity u2 in this direction. Imagine the situation when u1 is greater than u2. What happens? After some time, these two bodies will collide. This is m1 and this is m2. So both the bodies will collide. During the collision, the linear momentum exchange takes place. The linear momentum transfer takes place from here to here, from here to here, according to their masses and their initial velocities. This is during collision condition. This is before collision condition. Before collision, law of conservation of linear momentum. According to the law of conservation of linear momentum, m1u1 plus m2u2, which is equal to the linear momentum of the system after the collision. Right? What is after the collision here? So this is the body of mass m1 moves with a velocity v1. v1 is the final velocity of the first body, right? So m2 is the mass of the second body. After the collision, it will be moving with a velocity, it's v2, it's the final velocity of the second body. Clear? Now, according to the law of conservation of linear momentum, total linear momentum of the system before the collision will be equal to total linear momentum of the system after the collision, right? So this is the basic formula we have, and we have derived also. After that, common velocity situation we had discussed. When you come to the concept of common velocity concept here, m1u1 plus m2u2 is equal to m1v plus m2v. That's a common velocity. Clear? From here, common velocity v suffix c, right, which is equal to m1u1 plus m2u2 divided by m1 plus m2. So this is the general equation. So general equation is this one, and it's a common velocity equation. And we had discussed about recoil velocity of a gun or velocity of the rocket. Clear? Recoil velocity of a gun and velocity of a rocket. And those formulas we have discussed. So which is V2 is equal to minus M1 V1 by M2. What is M2 here? So I am writing here. This is a recoil velocity of a gun or velocity of a rocket. Here, M2 is mass of the gun. Clear? Mass of the gun. V2 is what? Recoil velocity of a gun formula, right? So let us solve. Let's try to recollect, try to remember all these three basic formulas. It's a general equation, common velocity and recoil velocity. Even in the 11th standard also, you will be getting the numericals based on this law of conservation of linear momentum, right? From these formulas only. Let's solve how the questions will be asked from this concept in today's class, right? Now, let me take the first question, first example. There is a body of mass m1 is taken as 100 grams. Commonly asked question, I'm telling you. Second mass let's take, which is 50 grams. Clear? Now, initially the first body is moving with a velocity of 2 meters per second. Imagine the second body is moving with a velocity 1 meter per second. I am giving some random values, let's check. And after the collision, the first body is moving with a velocity of 1.5 meters per second. After the collision, what is the velocity of a second body? That's a question asked. Are you ready to solve it? This is the basic level of the numerical we are discussing first, right? So what is the question? Mass of the first body is given 100 grams, and you can see here. This is the first body is 100 grams, and mass of the second body is 50 grams. This is 50 grams. And see the situation. Initial velocity of the first body is 2 meters per second. Initial velocity of the second body is 1 meter per second. What I have told you, these two bodies need to collide. That is what the law of conservation of linear momentum tells. Before collision and after collision, there must be collision between the two bodies takes place. Right? To get the collision between the two bodies, the one and only condition is this body must run faster than this body. Yes or no? Imagine you are running with 1 meters per second and your friend is running behind from you, right? With 2 meters per second on the same line. Imagine on the same line what happens. So he is running faster than you. Definitely he will just collide if there is no space the other side. You got the point? So that's the one and only condition for the collision occurs. U1 is greater than U2. Yes, it is satisfied. Alright? If they have mentioned that U2 is greater than U1, and definitely you can get there won't be collision takes place. Right? Now, let's come back to it. What is our aim? Our aim is to find V2. The major formula we have M1 U1 plus M2. I am writing here. I am going to solve this question from this formula. M1 U1 plus M2 U2, which is equal to M1 V1 plus M2 V2. Are you ready now? M1. Let's substitute everything. M1. What is M1 here? That 100 grams, that is 10 square into gram need to be converted into kilogram. So that's 10 raised to minus 3 kilogram, right? M1 is done. What is M1? 100 grams. 100 grams can be written as what? 100 into 10 raised to minus 3 kilogram. So this is M1. What is U1? U1 is 2 meters per second. Clear? Plus, why we have converted it grams into kilograms. I have told you and I keep on telling you from the day one. These units are in SI units. You can see meter per second, meter per second, meter per second. But the gram is not the SI unit. It's a CGS unit. You need to convert this gram into SI unit called kilogram. Right? That's the reason I have done it. M2. M2 is how much here? 50 grams. What I can write? 50 into 10 raised to minus 3 into U2. What is the second initial velocity? 1. That's a left hand part is done, which is equal to the right hand part. What is right hand part? M1 is 100 grams. So once again, 10 square into 10 raised to minus 3 kilogram into V1. V1 is 1.5 meter per second. Clear? Plus M2. M2 is what? Similar to this, right? Which is 50 into 10 raised to minus 3. It's M2 V2. So I'm writing it V2. Done. Now, only thing you need to calculate the V2. Just a basic arithmetic operations I am going to use here, right? See, 10 raised to 2 into 10 raised to minus 3. It's a 10 raised to minus 1. 2 minus 3 minus 1. If you feel that you could solve the further part of this same question, you can do that. Find V2. Just pause the video and find the answer and again start the video and recheck your answer. That's it. So 10 raised to minus 1 into 2 plus this is 50 into 10 raised to minus 2 can be written as 5 into 10 raised to minus 2 into 1, which is equal to 10 raised to minus 1 into 1.5 plus 5 into 10 raised to minus 2 into V2. Yeah. 10 raised to minus 1. I can write it as 1 by 10. So this is 2 by 10 plus, so this is how much? 5 by 100. 10 raised to minus 2 comes denominator, that is 100, which is equal to, right? See, 2 by 10 plus 5 by 100, which is equal to, what is this? This is 1.5 by 10 plus 5 by 100 into V2. Clear? Now 2 by 10, it's 0.2 plus 5 by 100, 0.05, which is equal to 1.5 by 10, it's 0.15. Is it clear? 0.15 plus 5V2 by 100. Clear? Done? Now, so this is how much here? 0.2 plus 0.05. So this I can write it as 0.25. This plus 0.15 comes to the other side, that will be minus 0.15, which is equal to 5V2 divided by 100. 0.25 minus 0.15, how much it is, right? I can write this is a 0. So this is 0.5, this is 0, 2 minus 1, it's 1, 0.10, which is equal to 5V2 by 100, okay? Just cross multiply, this is 0.1, so 100 into 0.1, which is equal to 5V2. So this 10 and point comes here, it will be 1. 1 into 10, it's 10 is equal to 5V2, and this is 5 2s. So V2 is equal to how much? 2 meters per second. V2 is equal to how much? 2 meters per second. V1 is how much? 1.5 meter per second. V2 how much we have got? 2 meters per second. One more point I tell you, I would like to tell you one more point. Just for your better understanding, this is advanced topic. Listen. V1 is how much? For example, let me write these values here. V1 is how much? 1.5 meters per second. V2 is how much? 2 meters per second. Which is moving faster? Which is moving faster? First body or second body? Second body is running faster. So this body is running slower comparatively. Is there any possibility of colliding these two bodies? Tell me. Is there any possibility of colliding these two bodies? Impossible, right? There is no further collision takes place. Once you come to the first PUC, right? There we'll be discussing the further collisions also. I hope you understand the situation and how the questions will be asked. Just the formula and the calculation part. That's it, right? Most of the students do the mistakes in this calculation, including the conversion of the units. That's it, right? Let's solve some more questions based on law of conservation of linear momentum. Let's continue the numericals, my dear students. A bullet of mass m1 moving with a speed x strikes a wooden block of mass m2 and gets embedded in it. The speed of the embedded block will be. Here two possibilities are there. Whenever this kind of questions seen by the students, when they see that a bullet of mass m1 moving with a speed x, they immediately recollect the concept of before firing the bullet, or before firing the gun and after firing the gun, right? So what is that? Before of firing and after firing. So this is the first thing will come into the mind, but it is wrong. In this case, there are not only bullet and gun. There's no information is given about the gun. There are two bodies, one is bullet and another one is wooden block. When we are talking about law of conservation of linear momentum, we must talk about the collision between the two bodies. What are the two bodies here which are colliding? One is bullet and the one is wooden block. So that's the reason we are not considering before firing and after firing condition. Clear? Now, before collision and after collision condition we need to consider. So, before collision and after collision, so the condition I am considering. I hope you got the point. Let's read the question once again. A bullet of mass m1 moving with speed x strikes a wooden block of mass m2. Just a wooden block which is kept at rest. They have not mentioned that the wooden block is moving. Imagine I have given already this example during the concept. So this is the wooden block. Okay, it's a wooden block here. There is a bullet of mass m1 moving with speed x, right? This is u1, clear? Which is moving in this way, This is the wooden block of mass m2 is given and the u2 will be 0 because it is at rest. Now, after the collision, so this is before collision, you can write the law of conservation of linear momentum. According to law of conservation of linear momentum, what I can write? m1u1 plus m2u2, which is equal to m1v1 plus m2v2. Let's concentrate before the collision. Before collision, what happened? Mass of the bullet is m1. Initial velocity of the bullet is x. Clear? Plus mass of the wooden block is m2. Initial velocity of the wooden block is 0. Clear? Let's concentrate on after collision. What happens? This and gets embedded in it. The bullet is moving towards the wooden block and gets embedded in it. Embedded in it means the bullet moves inside of it. Right? So this bullet is embedded in it. I have told you already in this case. In this case, for some time, depends on the velocity of the bullet which is striking the wooden block. For some time, both the bodies, so here you can see m2 is this body and m1 is inside of it. So the combination of m1 and m2 together will move with some velocity. So that is called common velocity, right? That's what they give. The speed of the embedded block will be. Embedded block means the block which is inside there is a bullet. So the speed of embedded block means they are asking the common velocity, right? So after the collision, first body, it's a bullet mass which is moving with a common velocity v plus m2 mass of the wooden block that is also moving with the same common velocity v, right? Now, left hand side what is remained? m1x plus 0 which is equal to m1 plus m2 both v, right? So both the v I have just taken common. So what is your final answer? So v is equal to, that's a common velocity and that is the same velocity, the speed of the embedded block. V is equal to what? m1x by m1 plus m2. To confuse you, in the options you check. They've given same m1x by m1 plus m2 with the square root. So that's wrong. So this is m2x by m1 plus m2. That is also wrong. Here m1x by m1 plus m2. Yes, correct. Right? So here m2x by m1 into m2. It is wrong. Sometimes the option may be m1x by m1 into m2. That is also wrong. Denominator, there must be sum of the masses. Check here. Like that you should check. Right? In a hurry, while writing the exam, commonly the students do mistake by even by getting the correct answer also while opting without checking proper sign, right? They'll be marking the wrong answer, right? Please avoid that. Now let's see the next question. Next question is theoretical. If you observe the previous years of the NEET exam question papers and even JEE exam question paper, the amount of theoretical questions are slowly increasing. Previously it was not like that. So that's the reason even in our assignments also you might have observed some kind of theory questions also are involved. One more theoretical question now. If there is an option for the soldiers to use rifles of different weights, if there is an option for the soldiers to choose the rifles of different weights, but with the bullets of the fixed weight, bullet weights are not changing, only the rifle weights are changing, the different weights of the rifles are available. They would prefer what? There are four options are given. Light guns because they can be carried easily, second option. Heavy guns because they can held firmly, heavy guns because they have less recoil, light guns because they have more recoil. I hope you could recollect the concept of recoil velocity of a gun. I had told you clearly V2 is equal to minus m1 v1 by m2. What they told, a mass of the bullet, weight of the bullet is same. That means this m1 mass of the bullet is same, right? When this is constant, so the recoil velocity is inversely proportional to mass of the gun. When a mass of this is about the gun, okay? When mass of the gun is more, recoil velocity will be less. Then the shoulders will not affect, right? Shoulders will not affect. So more mass, definitely they will prefer. More mass means more weight. So there is no difference between weight and mass. I've told you already. Just the mass is multiplied with acceleration due to gravity. That's called weight. So the weight of the gun is more. They will prefer because it will have less recoil. Let's check. Heavy gun only they will prefer. This is heavy gun and this is also heavy gun. So the light guns they won't prefer. Two options are eliminated. And let's concentrate on heavy guns because they have less recoil. Heavy guns, less recoil, it's a correct option. What happened to the second option? Heavy guns because they can held firmly. What is meant by the firmly held? So even light gun or heavy gun, they can hold firmly only. Firmly means strongly they can hold with the support of the shoulders, right? But that is not the correct option because they can held firmly even the less weight gun also. So that is how the questions will be solved. And are you ready to solve some more questions? Are you ready to solve some more questions? I hope you are ready, and let's solve some more questions now. So my dear students, let's see this question. And this is the question asked in a previous JEE mains exam. When your level of preparation is up to the JEE mains and advanced, the NEET exams and the KCET exams will be very, very easy way. Now, how the law of conservation of linear momentum questions will be asked in this kind of exams also I am going to show you now. Listen. A grenade having mass of 10 kg flying horizontally with a velocity of 10 meter per second, right? So what is the question given? There is a grenade of mass 10 kg. Let me draw the diagram for these respective questions, then you will understand far better, right? Wherever it's possible, try to draw a rough diagram related to that. A grenade of mass, how much? 10 kg. It is moving horizontally in this direction with a velocity of 10 meters per second. Then explodes. Look at here. There's no collision here. Here explosion. Law of conservation of linear momentum we could apply before the collision and after the collision. Before firing, after the firing. Before embedding means that is also a collision. And here one more important thing, and before explosion and after the explosion. Before the explosion and after the explosion. Explosion is due to the internal forces, yes or no? Explosion will not be due to the external forces. It is just because of the internal forces only, internal mechanism only, the grenade will explode. As long as external forces is not acting on the system, you can use the law of conservation of linear momentum, remember. Once there is an external force is acting on the system, you cannot use the law of conservation of linear momentum. right? Total linear momentum of the system is constant, remains same, unless, that means as long as external forces is not acting on the system. That's a condition, right? Here the grenade is moving in a horizontal direction with some velocity. That's what before explosion, and it is exploding into the two fragments, right? So this is 10 kg is exploding into the two fragments. Here you can see that's M1 and this is M2, right? And the larger fragment has a velocity of 25 meter per second and moving in the direction of initial velocity. Imagine, so mine is larger fragment is M2. So I have imagined that M2 is greater than M1. The larger fragment is M2 moving in the direction of the grenade velocity. It's 25 meter per second speed. Alright? Now, and the smaller fragment, I have considered M21 is the smaller, right? The smaller fragment has a velocity of 12.5 meter per second and in the opposite direction. So this is moving in the opposite direction with the speed 12.5 meters per second. This is before explosion and this is after explosion. See here, this is before explosion and this is after explosion. Is there any external forces acting on the system? No, impossible. Okay, so just apply law of conservation of linear momentum before the explosion and after the explosion and you get the answer. What is a requirement? The masses of the fragments we need to find out. And what is our aim? Our aim is to find M1 and M2. Finding is our aim. Our aim is to find M1 and M2. That's it. Are you ready? Are you ready now? What is M1 plus M2? Without solving any further part, I can write M1 plus M2 is equal to 10 kg. Will you agree with this? Everyone, will you agree with this? M1 plus M2 is equal to how much? 10 kg, because the initial grenade mass is 10 kg. After the explosion, that 10 kg is divided into two fragments. One is larger, one is small. One fragment may be 7 kg, another fragment may be 3 kg. One is 9 kg, another may be 1 kg, whatever it may be. So this 10 kg is only splitting, and I have my equation 1. M1 plus MP is how much? 10 kg. Are you ready now? Let's solve by using law of conservation of linear momentum. According to law of conservation of linear momentum, before explosion, what is the total linear momentum of the system? Before explosion, there is only one body called grenade. Total linear momentum of the system is m into u. What is that? 10 into 10. What I can write it is m into u, which is equal to, after the explosion, first body will have some velocity, second body is also some velocity. Alright? So what I have taken, m2 is greater than m1, right? So whatever it may be. First body is having some velocity, m1 into v1, plus second body is also having some velocity, m2 into v2. Clear? Now, let's substitute. What is m? Capital M is 10 kg into 10 meter per second. See, initial velocity of the grenade is 10 meter per second, which is equal to m1. m1 is how much? That we don't know. m1 into first body is moving with the velocity 12.5 meter per second, but in opposite direction to the initial direction, right? That will be minus 12.5 plus m2 into m2 is the mass, which is a greater fragment. That means larger fragment is moving in the same direction of the grenade. So that means this velocity I am considering as positive direction. It is 25 meter per second. It is. So what I can write, it's 100, which is equal to minus 12.5 m1 plus 25 m2. From the right hand side, I can take common 12.5. Okay, so 12.5, if I take common, it's 2m2 minus m1. Is it okay? 2m2 minus m1. So which is 100, right? So this is 100 divided by 12.5 is equal to 2m2 minus m1. 12.5 8s are 100. So 8 is equal to 2m2 minus m1. So I am writing the equation 8 is equal to 2m2 minus m1. Right? Imagine that's equation number 2 and we have equation number 1. Where is my equation number 1? See here, m1 plus m2 is how much? 10 kg, right? So what I can write, m2 plus m1 is equal to 10 kg. This is my equation number 1, right? Both the equations, if I add, what happens? Let me add both the equations. 10 plus 8, which is 18. 2m2 plus m2, it's 3m2. Minus m1 plus m1. See, minus m1 plus m1. I'm just adding left hand side and I have added right hand side part. So minus m1 plus m1 cancel here. So what is remained? 18 is equal to 3m2, m2 3, 6. So m2 is equal to how much? 6 kg. m2 is 6 kg. m1 is how much? How much is m1? Total mass m1 plus m2 need to be 10 kg. So then m2 is already there, larger fragment 6 kg and this must be 4 kg. Then you get the answer. Yes or no? So m1 is 4 kg. So these are the masses of the fragments. These are what? Masses of the fragments. Individually we have found. See, masses of the fragments are m1 is 4 kg, m2 is 6 kg. Whether your answer is correct or not, you can check according to these values and this one. Larger fragment is moving with a velocity 25 meters per second. What is our consideration? Larger fragment is m2, right? So m2 must be more out of these two values. m2 is 6 kg, m1 is just 4 kg. So our answer is 100% correct, right? Are you ready to solve some more questions? And let's. My dear students, most of the times there was a question even in KCET exams and the NEET exams. There was a question based on combined velocity. So let's discuss the basic level of questions, how they will be asking from the combined velocity topic, and let's see. There is a boy of mass of 50 kilogram. It's mentioned here. He is moving horizontally with he is moving with an initial velocity of 1 meters per second. Simple, 1 meter per second. There is a cart, this is the ground, and there is a cart which is a stationary cart. It's not moving initially. So it is a stationary cart. As it is stationary cart, its initial velocity is 0. Imagine it's u2 and it is u1 because mass of the boy is m1. I have considered a mass of the cart is m2, which is 5 kilograms is mentioned. I hope you understood the question. There is a boy. Look at here. He is the boy. So this is the boy moving horizontally and jumped onto this cart. So here we need to concentrate before jumping and after the jumping, right? After jumping, what happens? Before jumping, it is only m1, u1 only. After jumping, both the bodies will move with a common velocity. What is that? With a common velocity, they will be moving. The question is, find this common velocity. I hope you understand it, right? So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 u1. What is m1 u1? First boy, mass of the boy, which is 50 into initial velocity of the boy. It's 1 meter per second plus what is m2? Mass of the cart, that is 5 kg, into what is the initial velocity of the cart? They have clearly mentioned that initially the cart is at stationary position. That means it's 0, which is equal to, so mass of the person, it's 50 kg into final velocity of the person. Final velocity of the person and final velocity of the cart remains same. That's called the common velocity. It's v plus mass of the cart is 5 into final velocity v. So this is how much? 50 which is equal to the 0, right? 50v plus 5v. V if you take common, it is 50 plus 5. 50 is equal to v into 55. So this is 5 tenths and 5 11s. What is the answer here? I have got the answer. V is equal to, it's 10 by 11 meter per second, because all the units we had considered as SI units, meter per second, kilograms only. So that is how the questions will be asked based on combined velocity. Let's see one more question based on combined velocity. So this is a little interesting question. There is a body of mass, you can say 0.25 kg. Alright? Another body of mass 0.25 kg. Both two bodies I've considered. It's a before collision condition. Before collision, both the bodies are moving. This is moving with 3 meters per second and this is moving with 1 meter per second. I hope you understand why it is 3 meters per second and why it is 1 meter per second. As imagine it's mass m1, it's m2, so the collision need to be taken place. This is m1 and m2, and u1 must be greater than u2 here in this case. That's a condition for collision. Then only law of conservation of linear momentum will discuss, otherwise no possibility, right? So this is the first case, and after some time definitely there will be a collision takes place. This is the collision is taking place. So interesting thing is, after the collision, they had clearly mentioned that both the bodies are moving with a common velocity v. Find the common velocity. That's a question. How to find the common velocity? We have the formula m1 u1 plus m2 u2 by m1 plus m2. You can just substitute everything. Common velocity is m1. m1 is how much? 0.25 into 3 plus 0.25 into 1 divided by m1 plus m2. m1 is how much? m2 is how much? 0.25 plus 0.25. So common velocity will be equal to 0.25 from the numerator. If I take common, 3 and 1. Here 3 is left and plus here 1 is left, divided by 0.25. The denominator also, if I take common, here 1 plus 1, it's 2 here, right? 0.25, 0.25 cancel, and it is a 4 by 2. I can write it is 2. So the common velocity is 2 meters per second. Let me tell you one more interesting thing for you. Imagine the situation, both the bodies are moving towards each other with the same thing. The same question I am just reframing in this way. So this is the body m1 and this is the body m2 with the same speeds, but they are moving in opposite directions. Look at here, it's 3 meters per second, it's 1 meter per second. Both the masses are 0.25 and 0.25 only. Look at here, 0.25 kg. And this is also 0.25 kg, and after the collision both the bodies are moving together. Okay, same. What is the common velocity? That's a question. Right? What is the common velocity? Check it. What's the common velocity formula? m1 u1 plus m2 u2 divided by m1 plus m2. And let me write Vc is equal to m1. What is m1? 0.25 into u1, it's 3 plus m2, 0.25 into u2. What is u2? It's minus 1. That's important. By m1 plus m2, 0.25 plus 0.25. So common velocity is here 0.25 from the numerator. If we take common, 3 minus 1 is left. 3 minus 1 divided by 0.25. If you take common, it's 1 plus 1 will be 2. 3 minus 1, 2 by 2, cancel. 1 meters per second. I hope you understand. Clear? In this way the questions will be asked, right? So why I have just reframed the question here? Because when you are solving one question, as you have a lot of time right now, what you have to do is, when you are solving one question, you need to think, this question can be asked in what other manners? Clear? In what other ways this question can be asked according to your knowledge? Clear? So that you should think in this way also. The problems, numericals practice takes place for you. Okay, so get ready for the assignment based on this and the small previous topics, right? Including like recoil velocity and Newton's laws of motion and small concepts, right? Okay, all the very best.